The string primitive instructions optimize some basic actions with arrays. Now we're going to look at three basic ones: the move, the compare, and the scan. But keep in mind, everything we're going to talk about could be done with loops and the instructions you already know. So for just a second, let's consider the ESI and the EDI registers. In the ESI register, the S stands for source. In the EDI register, the D stands for destination. All of the instructions we're going to look at use the ESI register as the source register and the EDI register as the destination, which means you've got to set these up accordingly. In these instructions, the direction flag gets really important. If it's cleared, that means go from the source to the destination. In general, that's what you want, so make sure you clear it before the instructions. Here's an example. Suppose I want to copy a byte from string 1 to string 2. First, I set up the registers. Then I clear the direction flag to indicate let's go from where ESI points to where EDI points. Then I use the move single byte instruction. Now that's only going to move one byte. What if I wanted to copy the whole string? That's where the repeat prefixes come in. All of the instructions we're talking about operate on just one byte or one word or one double word. If I wanted to copy the whole string from the last example, I'd have to use a repeat prefix. Here's the table of them, and notice that they're all based on the ECX register and sometimes the 0 flag. So let's say I want to copy the whole string from string 1 to string 2. Here are the steps. First, I'd make sure that string 2 has enough room to hold string 1, including the terminating 0. Those of you that have some C programming experience have seen this sort of thing before. Number 2, I set up the registers. 3, I clear the direction flag. 4, I set up the ECX register to the number of bytes in string 1, including the 0. And then finally, I use the move single byte instruction with the repeat prefix. Now what that instruction is going to do is copy each byte from string 1 into string 2, and it's only going to stop when the ECX register is 0. Notice that string 2 might have some space left, but the terminating 0 marks the actual end of the string. As with the move instructions, if you're only going to compare two things, it really doesn't make sense to use these string primitives. But they do make a lot more sense with arrays. So let's start off with two word arrays, and we're going to compare them to see if they contain identical elements. First, we set up the registers, clear the direction flag, and set up the ECX counter. And we're going to use a repeat prefix that says keep on comparing each pair of words as long as they're the same. Now when that loop stops, one of two things is going to be true. Number 1, either all the elements are identical in the two arrays, or number 2, there was a mismatch someplace between two elements. In this example, the fourth elements of the arrays don't match, so the loop stops. Since there was a mismatch, we want to jump to whatever code deals with two different arrays. But if there was no mismatch, we don't take that jump. Instead, we're going to execute the code for when the arrays are identical. The last set of instructions we're going to take a look at are the scan instructions. Now this group becomes really useful when we're looking for one value in a string or in an array of some sort. It's important to keep in mind that the thing we're looking for is going to be in the AL register or the AX register or the EAX register. And the loop based on the ECX register is going to keep repeating until a match is found or until the ECX register becomes 0. For this example, let's use double words. Please notice that even though these are called string primitives, for this example and the last one, we've dealt with arrays containing numbers. Okay, so here's my array, and let's suppose I want to check to see if the value 75 is in it. The first thing I do is point the EDI register at my array. Then I clear the direction flag and set up the ECX counter with the number of elements in the array. After that, I move the value I'm searching for into the EAX register, since we're dealing with double words. Now, it doesn't have to be the EAX, it could be any general purpose register. But this time I'm not using the ESI register because we're not moving or comparing values between two different arrays. I'm looking for one value in one array. My repeat prefix says keep on scanning through the array until I find a match, or until the ECX register goes to 0. So when the loop stops, we again know one of two things is true. Either there was a match found, or ECX became 0. Here's the reasoning. If a match was found, the loop stops and the 0 flag is set. Otherwise, no match is found and the loop ends without the 0 flag being set. In other words, it's clear. So this line of code says, if the 0 flag is not set, jump to the code that deals with the no match condition. And if we don't take the jump because the 0 flag was set because of the match, then we execute this code. It's worth repeating that these string primitive instructions can be used to copy or to compare or to scan arrays of bytes, words, or double words. They're just shortcut ways of doing things that we could do with loops and compare instructions. All they do is save a few lines of code to accomplish the same things. And even if you don't use these yourself, you need to know what they're doing when you see somebody else's assembly code. This video is done. Thank you for watching.